Welcome to the IAS accredited and CSA certified manufacturing facility of Corle Building Systems. Corle Building Systems is located in a small town of Imler, Pennsylvania. We specialize in pre-engineered steel building systems. To begin the manufacturing process, all of our raw materials are received and stored at the south end of the plant. A rigid incoming inspection is performed on all the material to ensure it meets Corle high standards of quality and design specifications. Once the material is received and accepted, it is stored in specified locations in preparation to begin the manufacturing process. The manufacturing process starts at the plasma burn center, where we begin production of the rigid frame members. Here the material is loaded using a gantry system onto a series of in-feed rollers and transported to our burn center. Once the material has been transferred to the burn table, a CNC-controlled plasma torch head burns the webs out of the designated material to ensure accuracy. Several webs are nested on each plate. Once cut, they are individually checked and marked with a factory order number and a unique part number. Once checked in and marked, they are moved forward onto an outfeed table and offloaded with another gantry system onto a series of rollers, where they will be transported to the web splice station. Once the webs have been burned at the plasma station and transported to the web desplice station, the shorter webs are loaded onto a series of roller tables to create one longer magnetic gantry web. The AWS certified web splice process is performed by a weld head mounted on a speed-controlled track, with travel speeds dependent on the steel thickness of each web. While the webs are being burned out and spliced together, the flanges are also being made into rigid frame members. Here at the flange line, the CNC control punch and shear unit is capable of handling material 14 inches wide and 1¼ inches thick. All flanges and connection plates are computer generated and nested on designated bar sizes to once again ensure a high standard of quality within Corle Building Systems. Once each plate is flanged or sheared, it is driven onto an outfeed table and offloaded for the first piece inspection, which is performed and is given a specific part mark. Connection plates are then transported to our fit assembly area, and the flanges are sent to the next area in the process, the tack station. Here at the tack station, the webs and flanges join each other and begin the early stages of assembly into a beam. Once the web has completed the web splice, it rolls down the roller table to the tack station. At this point, the operator loads the necessary flanges onto the tack table and begins to center the web into the flanges. A 2 or 3 inch tack weld is placed to center the web. After the flanges and web have been tacked, rollers transport the beam to the next station, which is the submerged arc welding station. At this station, the beam is being pulled to the machine while simultaneously being welded at both flange web joints. Corle uses a submerged arc flux shield weld process at this station to ensure the highest quality welds. This process uses an AWS-approved powder flux to shield the weld from any airborne pollutants that could cause porosity while also maintaining a constant temperature. The flux powder bakes to the weld, maintaining the controlled environment, and as the weld cools, the flux slag is chipped off. Corle also inventories various standard mill sections. These sections are cut to length with a bandsaw and are used as end wall columns and end wall rafters. Once cut to the specific length, they are given an individual part mark and transferred to the fit assembly area. At this station, assembly of the rigid frames and end walls begins. Any necessary connection plates, stiffeners, and clips are added at this point. The Corle factory locates and welds all of its clips on the end walls of the rigid frames to ensure accuracy and ease of erection in the field. Once all clips, connection plates, and stiffeners have been tacked into place on the rigid frames, they are then transferred to our quality assurance department. Once a beam is transferred to the quality assurance department, each beam is inspected to ensure all clips and plates are correctly located on the beam. Once accepted by quality assurance, it is then passed on to the weld department. Pipe Room Automated Band A saw is a multi-point machining tool used primarily for cutting metal stock in preparation for other processes. Some buildings are engineered using tubular steel. The tube is a system designed to resist lateral loads, wind, seismic, and impact. The perimeter of the outside consists of closely spaced columns in the simplest embodiment of the tube that are tied together with deep spandrel beams through moment connections. All welders Corle welders are AWS certified to ensure the integrity of each and every building, and Corle employees and an in-house certified weld inspector inspect the welds of every beam that leaves the plant. Once a beam has passed the final welding inspection, it is transferred into our multi-station paint line and curing oven. Corle uses a high-quality, rust-prohibiting gray primer on all of its mainframes and end walls. The steel painting process begins with a large track system transporting steel into the paint application unit. Before being painted, each piece of steel is sent through the wheelabrator shot blaster to remove all dirt and imperfections. Next, the steel moves through the Global Finishing Systems paint booth. Paint is applied using a manual process. Once painted, the steel is sent through the curing oven, providing a long-lasting, high-quality finish. The entire painting process is environmentally friendly, utilizing filtering processes and booth containment. This energy-efficient, state-of-the-art process improves product quality and drastically reduces painting and drying time. This is the Corle roll forming department. This is where the panel line produces an A and an R panel. The painted and galvanized coils are loaded onto a coil mandrel and fed through a roll forming machine. All information is automatically downloaded to the CNC controlled line, ensuring accuracy in both quantity and length. Corle also has a separate roll forming line to produce a standing seam roof, available in all Corle standard colors and galvalume. All of our secondary framing, purlins, and girts are made in our DTR line. The coil is fed through the machine and runs into a series of punches and shears. All of the information for the material in terms of quantity and length is automatically fed from our drafting and design department to the computer online. Once each piece has been punched and sheared, it will pass through an automatic printer, which imprints the job number, length, and individual part mark on that piece. In the trim department, all pieces of trim are made on a CNC-controlled machine. Corle provides a wide variety of standing trims, including gutters for standing seam roofs, screw-down roofs, downspouts, brake trim, base trim, J-trim, corner trim, and more. Our Trump machine utilizes laser technologies to cut out a specific area for easy erection in the field. Of course, no building would be complete without hardware. Here at the Corle Building Systems Hardware Department, we warehouse thousands of pieces of hardware such as fasteners, nuts, bolts, eye bolts, banding, closures, roofing clips, and more. After the production process is complete, all building components are carefully loaded onto Corle trucks and delivered to the job site by Corle employees, ensuring safe and on-time delivery. This concludes our tour of the Corle Building Systems manufacturing facility. We hope you've enjoyed viewing the processes involved in making a high-quality, custom-designed Corle building.